Momentum is the tendency for the object to keep moving once it's in motion, and it's the amount of motion possessed by a moving object and its product of mass and velocity. You can work out the change in momentum, which is measured in kilograms per meter per second, by multiplying mass in kilograms by velocity in meters per second. Your centre of mass is a contributing factor to your stability, which relates to how difficult it is to move the body from a balanced position. Your centre of mass is the point at which the body is balanced in all directions. As your body moves, as does your centre of mass. So as you can see in the image on the left, when the player lifts their leg, their centre of mass shifts so that they don't fall over. Gravity acts downwards on the centre of mass, and force can also be applied through the centre of mass in a linear motion. So, for example, if you are in dance and you wanted to do an arabesque, your centre of mass would need to be shifted forwards so that you don't fall backwards when you lift your leg. Some factors that can increase stability is lowering your centre of mass, keeping the line of gravity within the base of support, widening the base of support, and having more points of contact. For example, on the picture on the right, we can see a rugby player in a tackle. They need to be stable so that they can win the tackle and so they don't fall over. They do this by widening their base of support, by widening their legs and bending their knees so that their centre of mass is lower. The rugby player will also need to be able to keep their line of gravity within the base of support, and this will be easier as the base of support is now wider. More points of contact means that there are more parts touching the floor. For example, a person standing on one leg has 1 point of contact, whereas someone standing on 2 legs has 2 points of contact. For example, a gymnast will be more stable performing a headstand than a handstand, because they will have 3 points of contact, one being their head, one being their right hand and one being their left hand, instead of 2, which is just their hands. However, in some sports we do need to remove stability in order to complete a skill. So, for example, in gymnastics, when performing a cartwheel, you need to move your centre of mass to the side of your base support so that you can complete the skill. So on one leg the base of support is small, and if you lift the leg and move your weight slightly over one leg, you will move in that direction. For our numerical model, we are looking at basketball players, and we want to measure their force that they apply and their speed. By doing this, we are measuring their vertical jump and their 30-metre sprint. To measure forces, ideally we would use force plates, and these are basically scales, and they measure the force that is applied to them at around 1,000 times per second. So when we jump on these plates or run on these plates, they measure how hard and the force and the pressure that we are forcing onto the plates, and for how long we have stayed in contact with the plates. Newton's laws state that for every force that is applied, there is an equal and opposite force that is given back to us. So as we put force onto the plate and onto the floor and the plate will give us the same amount of force back. This is another way that the force plate measures and gives us a result for force. Another ideal way that we can measure movement in skill is to use a camera. This camera can split a movement into different sections so that we can analyse the movement using angles and software such as Dartfish. This can help us be specific in the angles and therefore the forces that we are producing. And lastly, you can use a combination approach, also known as Vicon. This is where you use force plates, but you also use 3D imaging, which is in the top left hand corner, and this produces a 3D image of what the player is doing. This can also help us see their angles and the way that the performer is producing the skill and the force. Lastly, another way that we can measure speed, ideally, would be to use light gates or timing gates. These are where there are small lasers that are passed through a gate, and when you run through the gate, the laser is triggered and it measures how fast. So if you put multiple speed gates up, each time you go through a speed gate it will measure the time that it took, and then you can split your 30-meter sprint time into 5-second gaps. Something that you must consider when setting up a camera for motion is the camera settings, so the shutter speed, the height the camera is placed, the distance the camera is from the subject, the angle that the camera is facing the performer, and the plane of motion that the performer will be performing in. For our method, we weren't able to use the force plates, so instead we used jump mats. These mats are round rubber mats and they have a string onto them, and they have a waistband that goes around the performer. Before the performer jumps, you have to calibrate the jump mat by twisting the dial that you can see in this picture to make sure that the string is really tight against the performer. The performer then does the vertical jump and the string stretches. You then measure the string and the string tells you how high the person has jumped. You can then put this into an equation and work out the force that's been produced to jump at that height. Another way that we measure movement of our performer is using a camera. The camera that we use may not be as advanced as the camera that we would like to use. We can still adjust different settings like the shutter speed. When using a camera, it's very important that the camera is set up correctly. There are many different factors that we need to look out for when we set up the camera. One of these is the angle that the camera is placed at. So if we're doing a vertical jump and the camera is placed midway throughout the performer's body, when they jump we may not be able to see the top of them. So we need to make sure that the camera is positioned far enough back so that we can see the whole of the performer in the frame of the camera, and so that when they do jump we will also still be able to see the whole of the performer once they're up in the air. Also, something I forgot to say for the ideal method is that with the super slow-mo camera you can get a camera that produces 1000 frames of a photo per second, and this would allow us to break down the motion more easily. However, for our method we weren't able to get these cameras, so we just changed the shutter speed. From the picture on the left we can see that shutter speed affects how clear and how many frames are taken and how quick the shutter closes on the camera. You can see that the lower the shutter speed, the more blurry the image. However, the faster the shutter speed, the more clear the image. One issue with the shutter speed is that if the shutter speed is too fast, there's not enough light entering the camera, so the photo can be really dark and then it may be too dark to see. So when taking pictures of our performer, we need to make sure that the shutter speed's fast enough that we can clearly see what's going on, but not too fast that there's no light entering the camera. Another way we can improve this is to have a large light that we can shine on the performer when they're doing their skill, so that we can see them more clearly and have a higher shutter speed. Some important factors that we need to consider when setting up our camera are the planes of motion, the distance the camera is from the subject, the angle the camera is facing the subject, the field of view, which is the height of the camera, the width of the shot, etc., and the image size. When setting up your camera, you have 4 key camera setup points that you must check before you can carry out your experiment. So basically it is the triangulation, and that's shown in this image. So basically the field of view that the performer will be in, you need to make sure that the camera can see that, and basically you want to have a triangle shape. So this is where the camera can see, this is how far the performer will be moving, and then you want to make sure that the lens and the view of the camera from here shows from all the way to one side all the way to the other side, so you can see the whole length that the performer will be moving. Another factor that you need to be aware of when setting up your camera is the spirit level. If your camera is being set up on a tripod, there is usually a spirit level, which is shown like this, and it has a bubble of air. This bubble of air will move from the left to the right depending the way that you tilt the spirit level. We want the spirit level to be in the middle, meaning that the little bubble of air should be within 2 lines that are shown in the middle. This will affect the way that the camera shows us what the performer is performing. So if the spirit level is in the middle, then that means that the camera is straight. And this is very important because it may cause perceptive error if it is not straight. Another factor that we need to look out for is the tilt and the roll. These can be shown on this diagram and this diagram. So the tilt is to make sure that when the camera is on the tripod, it is not wonky. This can also lead to perceptive error, and that's the same with the roll. The roll is having the camera so that it is leaning forwards or up. So we need to make sure that the view is straight and not going down, otherwise it can lead to a perceptive error. But if you need the camera to be looking at a lower part of the performer, then instead of angling the camera down, you need to physically move the camera downwards so that it is straight, and so that the roll and the tilt and the spirit level are straight, so that you get a perfect angle of the performer. This picture down here shows you the perceptive error that you may see. So if the performer is running from the 10 meters to the 90 meters, this will be the clearest view. However, from this angle, you may get the wrong angle and you may not be able to see the correct angle of the player's legs, for example. So if you wanted to evaluate the angle at the knee, it may not be correct because of the angle that the camera is facing. Another error to be aware of is the parallax error. This is where, when you're taking reading levels, if you look at the level from too high up, you may read the score wrong, and the same from if you do it from too low down. So the eye level needs to be completely in line with the thing that you are measuring. So for example, if you're measuring the angle at the knee, the camera needs to be completely in line with the knee joint, or it may lead to a parallax error. If any of these do occur, this could lead to poor data collection, poor footage, and then poor data analysis. If your data analysis is poor and your footage is poor, this could then lead to false conclusions. So you may be telling your athlete that the angle at their knee is wrong when it may be right, but you do not know because your evidence and your analysis is wrong because your data collection was wrong.